Happy Easter, folks. Let's do some maths. Okay, so starting off here, we've got an area is 40 centimeters squared, so we should write down the formula for area. There are about 5-6 area formulae you should know. This is one of them. This is equal to 40. What do we need to do? We need to find what radius is to start with. Then we're going to have to find the diameter when we're done. So we'll divide by pi. And we'll get that r squared is 12.73 dot dot dot. And then we want to square root that to get what the radius is, which is 3.568 dot dot dot. And then we want the diameter. So the diameter would be 2 times that. So double it, and you get your final answer of 7.14 centimeters, because the units were centimeters squared. Okay. This is an interesting one because it's kind of a proof. And I think normally I'd say put a number in and see what happens to it, but it wants you to show this is always the case. So we're actually going to start with a percentage. And we're going to say, suppose we start with 100%. 10% of that is 10%. And then if we add that on, we'll get 110%. And then let's add another 10% onto that. So if we divide it by 10, that gives us 11% this time. Add it on. You've got 121%, which is a 21% increase. So you could argue it that way. That's one way. Another option would be to use multipliers. So remember, for a 10% increase, that's the same as a 1.10 multiplier. So if we were to do it twice, it would be that multiplier squared, or times by itself. If you do that, you get 1.21. And that represents also a 21% increase. What I think would not be valid is if you picked like a number like 40, increased it by 10% twice, and showed that was a 21% increase. We need to show this is generally true, not specifically true. Okay. Similar triangles. So, general strategy is we want to draw both triangles out, and then find out what goes from one to the other. So let's do that. Little triangle and big triangle. This one is ABC, and it's got 8 and 6. This one is ADE, and it's got 18, and it's got 6.25 plus a bit, hasn't it? Okay, so we can't put that on just yet. But we can work out what the scale factor is, because we're going from 8 to 18. So 18 divided by 8 tells you that is times by 2.25. And so if we want to work out the side lengths here, that's what we're going to need to do. Now the question is, we want to work out AC, unfortunately, but let's see how it goes. So 6 times 2.25, going to give us 13.5. We can say that this length here is 13.5. But the question is that we want to find the length of AC. We want to find this x here. Okay. And what do we know about it? Well, we know that this length here, AE, is x plus 6.25. Okay? And we also know that if we multiply x by 2.25, i.e. the scale factor, this is what we get. So let's write that out as an actual statement. We know that if we do 2.25 times x, we get x plus 6.25, and then you've got some algebra you can actually solve. How do you solve it? Well, we're going to take away x from both sides. We're going to divide by 1.25, which I think is 5. Yep. And that's the length that we're trying to find, so that is 5. That one is fairly fiddly, I will say. Right. Bit more algebra to solve. You might prefer to write this as a decimal. Or you might prefer to have this as fractions. If I was doing this as the decimal, I would say 0.25w is 35 minus w. I'd add w to both sides, and I'd divide by 1.25. And that'll give me that w is 28. But you might prefer working in fractions. In that case, the first thing I would do is multiply everything by 4. This would give me w over here. This would give me 140, take away 4w, add the 4w across, divide by 5, 28. So you've got options, whatever works, works. Lastly, w is greater than 1, write in order from smallest to largest. Now, obviously we could think about this and, ponder like, evens and odds and what happens here. But it says it's greater than 1 and this will always be true. So let's just pick a number that's greater than 1. Let's just say w equals 2 and work this stuff out. So 2 to the power of 0 is 1, because that's anything to the power of 0 is 1. 2 cubed is 8. Fair enough. 2 to the minus 2. Now this might be a non-calculator paper, and it's worth remembering this. That means 1 over 2 squared. So that's a quarter, or 0.25. And what about this one? Well, we know that simplifies to w to the minus 1, which is 1 over 2, which is a half. So looking at the numbers from smallest to largest, the smallest is w to the minus 2, then w cubed over w4, then w0, then w3. You could have also just looked at the sizes of the powers, I suppose. Oh well, let's move on. Okay, a bit more indices for higher. Work out 5y to the 0. Well, we know that anything to the power of 0 is 1, but it's only y that's to the power of 0. So this is 5 times 1. This is 5. Whereas this one, the whole thing is to the power of 0, so the whole thing is just 1. Important distinction there. So the brackets means that all of this is to the power of 0. Okay. Standard quadratic, what do we need to do? We need to make one side equal to 0 before we do anything. Then we need to add to minus 1, we need to times to minus 42, and the numbers that do that are 6 and minus 7. So x plus 6, x minus 7 equals 0. Then we need to flip our signs at the end, so x is equal to minus 6 or x is equal to 7. You could of course do that with a quadratic formula, but again you'd have to make one side equal to 0 first. Okay. Ooh, a bit of trigonometry. Okay, so this looks like SOHCAHTOA or Pythag because we have right angle triangles. We need to find x, and we need to know something else about this bottom triangle. So we're going to find y first. So we're going to do this in 2 steps. First, let's find y. We've got y here, we've got 8, we've got 56, got a right angle. And then we should label up what we've got. So this is the hypotenuse, this is the opposite, so this is going to be SO. In particular, we're trying to find the opposite, so we're going to multiply, and we're going to say that y is equal to sine 56 times 8, which is going to give us 6.63. Okay, now we've got that, we can plug it into the bottom triangle. We've got 43, we've got x that we're trying to find, and we've got 6.63 that we know. Again, label them up. So this will now be the adjacent side. X is the opposite that we're after, so it's going to be TOA. We're trying to find the opposite again, so that's going to be a multiplication. So x is tan 43 times 6.63. This gives us 6.18. Units are centimetres. Cool. Okay. Next up we've got a histogram. Now histogram wise, the important thing to bear in mind is this triangle. I'm sure I get this the right way around. Frequency on the top, class width, and frequency density on the bottom. Yeah. So those are the key parts of a histogram. We've got frequency density we can see on the left hand side here. Class width is how wide these bars are, and then frequency is how many people they represent. So in this case, because we're trying to find the frequency, which is this one here, we're going to have to multiply the other two things together. So this is going to be class width times frequency density. Now let's write out the sum for the first one. The class width is 300 because that's how wide the first bar is. And we can fill in all the other widths. We could look at the graph, or we could just see what's the difference between these two. And then the frequency density is obviously the height of these bars, so times 0.3 for the first one, times 0.54 for the second one, times 0.7, times 0.38. You get the idea. And then work them out, and that's your frequency. So we have got 90, 108, 70, 76, and 40. Now, you are often asked about numbers of people in histograms, and this is how you find frequency. You find the area of those bars. So quite often we'd have to go like a couple steps further than that, but that's it for today. Okay, and that leaves us with higher plus. Excellent, a proportion question. Been a while. So remember, inverse proportion, that is going to be 3 lines. A is mentioned, cube root of B is mentioned, so we're going to have to write cube root of B. And then what do they times to? So when A is 60, B is 3.375, so we're going to have to do the cube root of 3.375, which is 1.5. So you can put 1.5 there, and we could say they always multiply to 90. Find B when A equals 90. So we'll fill in a 90. We'll fill in a 90 here, because that's always the same. And then what times 90 gives 90? It's 1. So the cube root of B is 1. So B is 1 cubed, which is also 1. Dead easy way to get those 4 marks if you can learn that table. Okay, another graph one. Equation of a line perpendicular to line 1 that passes through the point A. So we've talked about this quite a lot this week. Perpendicular means we have a negative reciprocal of the gradient. So let's do that first. We want to know the gradient of this line, and we want to do the negative reciprocal. As that line's in red, let's write this in red. So gradient of line 1. Draw a triangle on it. I'm going to draw my triangle up here so it's out of the way of A. That goes up. Okay, be really careful here. It doesn't go up 4. It goes up from 2 to 10. That's actually 8. That represents, you're not counting squares, you're counting units or coordinates. And similarly, it doesn't go across 4 either. It goes across 2. So the gradient of that is 8 over 2, which is 4. So our negative reciprocal gradient is equal to minus 1 over 4, and that's going to be our value of m. Very tricky, that. Okay, it also goes through the point A. What would we call the point A? I would call that 0 minus 5, because it's clearly between minus 4 and minus 6. So that's got our value of m. We've also got that x1 is 0 and y1 is minus 5. That's actually the intercept, isn't it? So we could go straight ahead and say like y equals mx plus c at this stage. So let's do that. This is our c. So y is equal to minus a quarter x minus 5. Okay, so second part of this question, we've then got to find the shortest distance between line 1 and the point A. Now, the shortest distance is always found at a right angle to it. So if we imagine if we were to draw the line. Now, I had to think about this because it seemed quite confusing, but your line's basically going to look like that for minus a quarter x minus 5. It doesn't look like a right angle here, but that's because the scale is all off, because it's going up in 2s and going across in like halves. So yeah, it would actually be in that sort of region. Anyway, we want to find this sort of intersection point. We want to find where those 2 lines cross. We'll call that B. And for that, we could essentially think about a little triangle maybe. Now we're going to have to find the point B, aren't we? So let's say that. Find B. Now the way we find where any 2 lines intersect is by setting their equations equal to each other. Now we know the equation of the line that goes from A to B, because that's what we did up here. But we also want the equation of line 1. And we've got its gradient already, which is good. So we know it's y equals 4x. and we can see clearly it goes through the y-axis at -2, so it's y equals 4x minus 2. So to find b, we need to solve those two equations. We need to set them equal to each other. So 4x minus 2 equals minus a quarter x minus 5. Okay, what do you do from there? When you get all the x's on one side, that'll give us 4.25x, 4 plus a quarter, and then add 2 across the other side, say that's equal to minus 3. We'll then divide minus 3 by 4.25, and we'll get that x is minus 0.706. And how do we get y? Well, we know one of the equations of the line is y equals 4x minus 2, so let's sub it into there. That'll give us that y is minus 4.824. Okay, so what do we do with this? Well, we want to find the distance from A to B, because the shortest distance is always at a right angle. And that means we want to find the difference in x and the difference in y between A and B. So the difference in x is equal to, well, just 0.706 because it goes across that far. And the difference in y is going to be minus 5, take away this thing, which is going to be 0.176. To get the distance between the two, you then need to do some Pythagoras. So distance is the square root of 0.706 squared plus 0.176 squared. All square rooted gives us 0.728. It's an awkward question, isn't it? Yeah, well, nice one. Let's move on. Last question then, square-based pyramid and a frustum. Okay, so a frustum is any like cone pyramid that's had the top cut off. This looks like another scale factor question. We've got perpendicular height. We want to find the volume of a frustum. And the way we find the volume of this is by like taking the big pyramid minus the little pyramid. So we're going to do eventually big pyramid minus little pyramid. That'll give us the rest of the pyramid. Are there any of these that we can do already? Well, we know it's square-based pyramid, both of them. We know that pyramid 1 has a base length of 12. We know that this has a base length of 4. And we know that the perpendicular height of this is 15. And then we can use some scale factors. We can think, well, what got us from here to here? We divided by 3. So that would tell us that this height here is 5. I think we can actually avoid using scale factors. Excellent. Because what we can do is we can just use the formula for the volume of a pyramid, which is third times the base area times the height. So we're going to do that for both pyramids. And we're going to get the volume that we need. So the base area for pyramid 1 is 12 squared, is 144. And the height is 15, because we're told that. The base area for the little one is 4 squared, is 16. And the height is 5, because we're told that. And that's all we need to do. Which gives you 693.3 recurring centimeters cubed. Happy days. And that's it. Cheers, folks. Hope it helped, especially that last line one. See you tomorrow.